Okay, in this video I'm going to discuss an example of an exponential random variable, and I'm using Maple again here, and that's because my pen pad is broken. So again, I hope the white background is not too much of a strain on your eyes. Please do let me know it is, and maybe I'll be able to find the time to go reproduce these videos. Okay, now because I'm doing this in Maple, I'm going to be typing out a little bit of a paragraph here to describe the situation in which I'm using my random variable to model a random quantity. Because I'm using Maple, it's going to look a little weird. I've got an indent here on the left side, but I can't figure out how to have it give me an indent on the right side, so bear with me on that. And the situation is going to be that on average a user logs on to a server every 3 minutes. So maybe a network administrator would be interested in this kind of a situation. Let X be the number of minutes until the next user logs on to the server. Okay. Now, if I were counting the number of people that were logging onto the server in a given time, then that would be a Poisson random variable, right? Because I've got a certain rate at which people are logging onto the server, and I want to know how many people actually log onto that server. Here, though, I'm not looking for the number of people that log onto the server. I'm looking for a time. My random variable is a time, and it's a waiting time. It's a time until the next person logs onto the server. And that's modeled by an exponential random variable. Okay, so X is an exponential random variable. And we need to specify its parameter. Its parameter is, let's see if I can find lambda here, is lambda equals to 1/3. And actually, let me put that in text so that it won't turn it into a fraction like that for me. And what we're going to do with that is we're going to estimate the probability that no one will log on to the server in the next 3 minutes. Okay, so there's our situation, and I'm going to make all this a little bit smaller so that we have more room here. Let's put it size 20 font. And I'll continue to work with that 36 font. So what we're seeking is the probability that my random variable X is greater than or equal to 3. Okay, since X is the number of minutes till the next person logs onto the server, if no one logs onto the server in the next 3 minutes, then X has to be at least 3. The next person's going to log onto the server at least 3 minutes from now. So I want that probability. And to compute a probability with a continuous distribution, I integrate. So I'm going to integrate from 3 to infinity. Let's see, infinity, and wow, that's ugly. Let me see if I can change the font size on the 3 and then infinity. Let's see here. Can I change you to size? How about 26? There we go. That's a little bit prettier. Okay, of my PDF. Okay, so that's what we're going to be calculating. Now, what is my PDF? Well, for an exponential random variable, the PDF is equal to lambda, that's 1/3, times e to the power of negative lambda, that's negative 1/3 in this case, times x. Okay, and that's my PDF, so that's what I'm going to be integrating. And so my probability here, let's see, I'm going to make all this stuff smaller. Is, well, I integrate that PDF, but now I have a formula for the PDF, so I can plug that in. And I could just press enter and have Maple integrate this for me, but I'm not going to do that because you don't have access to Maple. Instead, what I'm going to do is integrate this using Wolfram Alpha. So we're integrating from 3 to infinity, 1/3 e to the negative 1/3 x. So we're going to do that here. Let's integrate 1/3 times e to the power of negative 1/3 times x, and we want to integrate that from x equals 3 to infinity. Okay, and you see that integral is actually 1 over e. Okay, it's not 0.5 like you might have thought it was going to be. It's just a little bit bigger than a little bit bigger than 1/3. Okay, so let's go back to Maple here. And we see that this integral is equal to 1 divided by e, which is approximately 0.367879. Let me make that bigger for us here. Okay, now why did I say you might have thought it was going to be 0.5? Well, that's because on average, we have someone logging on every 3 minutes. So you might think that, well, what's the probability that it takes at least 3 minutes for somebody to log on? That's 1/2, because on average it takes them 3 minutes. Well, what's happening there is, if someone thinks that way, they're getting the median and the mean mixed up. The median is the number that if I put here, I'll get a probability of 0.5. But 3 isn't the median, 3 is the mean. It's the average. Add them all up, divide by how many there are. Or in the language that we used in the last chapter, it's the expectation. Okay, so this probability ends up not being 0.5, but being just a little bit bigger than 1/3, and exactly it's 1 over e. Okay, so that was an example of an exponential random variable and computing a probability as well, using the PDF for an exponential random variable.